Do the Piecewise Functions worksheet. This is the first one. I'm going to give you another one that looks just like this next, so you can practice it again. But let's run through this and explain why you should have got what you got. First thing is this graph and state the domain range in zero. So here we have a piecewise function. Easiest way to do this is to do 3 x and y charts, one for each of these pieces. So for example, over here, I'm going to do an xy chart for 3x plus 5, right? And we want to now see, notice the lines underneath it. It means it's starting and ending with a solid dot, starting at -3 and ending at -1. So if I plug -3 into that, I get -9. -9 plus 5 is -4. -6 plus 5 is -1. And -3 plus 5 is 2. So I'm going to plot those points over here. So 1, 2, 3, 1, 2, 3, 4. And again, solid dot because there's a line underneath it. -2, -1, and -1 up 2. All right, so we have this little line segment right there. All right, next we have this guy. 2 plus x minus x squared, which is a parabolic. So this is going to be a sad face parabola. So 2 plus x minus x squared and xy for that. All right, so this time we're going to start at -1 and stop at +3. Okay, so if I plug -1 in here, I get 2 plus -1, which is 1. Okay. I'm going to plug 1 in. 2 plus 1 is 3. 3 minus 1 would be 2 again. Plug in 2. 2 plus 2 is 4. 4 minus 4 is 0. Okay. 3 plus 2 is 5. 5 minus 9 is -4. All right, now I want to talk about what this looks like. It's an x squared, meaning it's a parabolic equation. A parabolic equation either has to have a maximum point or a minimum point. So let me show you what I'm talking about. If I were to graph these, now look, it starts with a solid line, ends with a solid line. So these are solid dots. So at -1, I'm at 0. 0, 2. 1 is at 2. 2 is at 0. And 3 is 1. Okay. Now, a parabola should have a turnaround point like that, right? It's missing. So I actually have to find that, which would happen at a half. So I would throw a half into this, right? And to figure out what it is, and the reason why I'm doing that, it's 2.25. So I need to kind of know how high that actually went. All right, then next we have this guy. So 4 xy, and this is 3, 4, and 5. Again, double lines means it's going to be solid dots, and these are all going to be 4. So 1, 2, 3, 4. We got a little wedge up there. So that's what the graph would look like for our piecewise function. All right, the domain. So domain means from left to right. So we start here. And it looks like we go all the way to here. So we start at -3, and we go all the way out to 5. That's my domain. Now my range is special. Range is how low to how high. Notice we start down here at -4, and we don't go straight up to this. There's like a blank area here, which is why we needed to know what the 2.25 was. So I'm starting down here at -4, and then we go up to 2.25, and then there's a break in the picture. So that's the highest we reach. Then it jumps up to 4, so we have the union 4, like that. So leaped. Zeros, that's everywhere it hits the x-axis. So you notice it hits 3 places, here, here, and here. Maybe this is 1, 2, so that's x equals 2 it hits. It also hits at -1. And it also hits here. Now we can't guess the location. This is this equation, 3x plus 5. So I'm going to set 3x plus 5 equal to 0 to find the exact location where that is. And that happens at -5/3. So those are the 3 zeros. So don't guess a location, actually get the exact number. And is this a function? Does it pass a vertical line test? No, it fails right here at -1. So that would be no. So that's the top part. All right, now next we have the composition of functions down here. This is calculate h of f of g of 5. So I'm going to do this first because that's what's closest. So I plug 5 into here, I get 10. 10 minus 1 is 9. Square root of 9, so the square root of 9 is 3. Then I'm going to plug 3 into f. Sometimes what you can do is cross them off as you do them to keep track. Then I have 3 into f. 3 times 3 is 9. 9 minus 2 is 7. Then I'm going to plug 7 into this guy. So 7 squared is 49. 49 times 2 is 98. So 99 should have been your answer for that one. All right, write as a rule and simplify. All right, so you get another piece of paper to help us out here. I'm going to take the G formula first, which is this guy, and plug it into H. And here's the H formula. So I keep the 2, and I'm going to plug where X is the G equation, square root plus 1. Now simplify means I want to clean this up. What happens when I square a radical? It goes away. Right? Then I'm going to distribute this. So I get 4x minus 1. So that is both of these put together. Now I got to take this and plug it into f. So I keep the 3. Where x is, I plug in 4x minus 1, and then subtract 2. So I have to distribute the 3. So that makes 12x minus 5 for that one. All right, next one. Write as a composition of functions. Okay, so we want to create something like this. Now my suggestion is work from the outside in. What's hanging off on the outside here? A radical. So which one of these has the radical in it? G. Now check out what the G also has. It has the radical. It also, oops, yes, the radical. It has the 2 and a -1. So check this out. Here's the radical. Here's the 2 and the -1. So if I scratch those little +1, specifically a 2 squared and a +1, look, that's H. Now scratch that off. What's left over on the inside? F. Don't forget to put your X in the parentheses there. And that would be the answer. All right, now, this next one. I want to solve G of H of F of X equals 3. Now, anytime I want you to do this, I don't want you to simplify it. It's actually easier if you leave it separate. So I'm going to go below here. So let's create this. I'm going to plug the F formula, which is 3x minus 2, into H. So that means I'm going to do 2, 3x minus 2 squared plus 1. So right now, this are these two together. And then I'm going to plug this into G. Now G wants us to take all of this with a 2 in front of it, minus 1 with a radical over it. So I'm going to make this, but now I have to set it equal to 3. And I'm going to solve it. Now the reason I left it like this is it's actually easier to solve it like this. Because here we go. How do you get rid of a radical? Square both sides, right? So if I do that, I have 2, 3x minus 2 squared plus 1 minus 1 equals 9. All right, now if you had to do this equation, I'm hoping you're thinking you would add the 1 over. So that would cancel. So I get 2, 3x minus 2 squared plus 1 equals 10. Oh, this had a parenthesis here, I missed. Now I'm going to divide by 2. So what's left over here now? 2, 3x minus 2 squared plus 1 equals 5. 2, 3x minus 2 squared equals 4. Divide by 2. See how it's slowly evaporating here? So I get 3x minus 2 squared equals 2. Now at this step, see the squared, and we take the square root. You get 3x minus 2 equal. Now remember, when you take the square root of something, it's plus minus radical 2. Now add over the 2, and look at that. That's the answer to the question. So right here, I'm going to put x equals 2 plus minus radical 2. Okay, and finally this bottom part, f of 3, means I go to the f picture, go to 3 on the x-axis, and it should be 4. This one, composition of functions. Do this first. G at 1 is 2. And that means I have to do f at 2, which is 3. All right, solve. F of x equals 3. Now that means I'm going to the y-axis on f of 3, which is right here. Draw a horizontal line. Now notice I hit twice. So there are two answers here. This one and this one. So this would x equals 2 and 4. And now this one is a two-stepper, but you always do this guy and this guy. So I go to the f picture at y equals 3, which we just did, and I got two answers, 2 and 4. So that means I have to go across here twice. I have to go across 2, and I have to go across 4. Now notice we hit a bunch of times. We hit here, which is above the 0. We also hit here, which is above the 1. And here, which is above the 3. And that's how you do that one. So this is the key to that piecewise function. So what I'm going to have you do is practice another one of these to see how you do.